What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to find the gradient and the y-intercept, but this time only looking at a graph. If we can find these two important bits of information, we're going to be able to make an equation out of any linear relationship that we see on a graph. All we need to do in order to get these correct is look for two things. The first thing that's really important is looking for the pattern. How does the line change over time? The other thing that's really important is what is the y-intercept, or the starting value. This start always occurs when x is equal to 0. So all we're really looking for is where does our line cross the vertical axis. The y-intercept is super easy to find, especially from a graph. All we've got to do is look at where does our line cross that big fat line in the middle, and you're going to get a mark. The only thing that is a little bit difficult to remember is you can't just write y is equal to 3 and be done. You have to write a coordinate. You need to tell us where we are in space. So instead of writing just y is equal to 3, you need to always write 0, 3. The first number of the coordinate is always going to be 0 because we're on that y-axis where we haven't moved side to side at all. So if we look at this blue line here and I said, hey, can you please tell me what the y-intercept is? All you've got to do is look at where does the blue line cross the y-axis. We can see that it crosses the y-axis up 1, so y is equal to 1, and x is equal to 0 because it's not on either side of the origin. So the answer for this is just 0, 1. That's all you've got to do. Another example, if we look at this red line that's got a negative gradient that's going downhill, we're still just looking for the y-intercept. Where does the red line cross the y-axis? We can see that it crosses at y is equal to 3. It's up 3 positions. So that means the y-intercept is 0, 3. Done. Of course, the y-intercept can be a negative number. This green line here is crossing the y-axis down from the origin, and it's down 4 positions. So that means our y-axis is just 0, negative 4. And that's a totally reasonable answer. So just the big pro tip is that the y-intercept is still a coordinate. Even though the x is 0 every single time in all of those examples, all you've got to do is write down x, 0, and then the y coordinate. Your answer is always going to be in a bracket. So if you get asked the y-intercept, 0, comma, whatever number the y is, that's going to get you full marks. The gradient is a little bit harder to find, but we're still only doing one division. So if you can just divide one number, either in your head or a calculator, you're going to get these questions right. The harder mathsy bit about it is just finding out what we need to divide. But all the maths we're doing is one division. So the gradient is the pattern that occurs during the line. What we want to find out is how does y change? How does this thing change up and down when x increases by 1? So the formula that we can use to find this is that the change in y, so the difference in the up and down or the vertical distance between 2 points, is divided by the change in the x, or how far across this thing goes. The best thing about this is because we're just looking for the change in up and down and the change in across, you just have to be able to count. My big pro tip is to draw a triangle on your graph, then just count up how many up, count up how many across. With our coordinates, we've always been doing across first and then up and down. But when we're looking for the gradient, because we're looking for the change in y, I'd like you to go up and down first. And we're going to see why in a second. So for this linear relationship here, I've been given 2 points, 0, 0 and 1, 2. So all I've got to do is find out how many did I go up for every single time I changed with x. And for this, I do want you to draw a triangle. So I've gone up 2 from my original point, from that 0, 0, and then I had to go to the right one spot. The gradient is just the change in up and down divided by the change across. So I just do 2 divided by 1, and the gradient is equal to 2. That's all the maths we have to do. And we didn't have to pick those 2 points. Let's say instead of the 1, 2, I decided to go to that top point all the way at the end where I've got 2, 4. The same thing still happens. What's the change in the up and down divided by the change across? This triangle goes up 4 and then across 2. So the gradient is 4 divided by 2, which is equal to 2, and we're done. This will be the same no matter what 2 points you pick. It's always going up by the same amount every time. And that's why it's a dead straight line. It's a repeating pattern. And this can even go across the x-axis. So here I've got -1, 4 all the way across to 2, -5. So this looks like a much harder triangle, but nothing actually changes. As long as we work out the distance between the two up and down, and then the distance across, we're going to get this right. Just as a little pro tip here, because this gradient is down already, I can see it's a downward slope. I know for sure that my answer is going to be a negative gradient. Just keep that in your mind as we go through this. So from that 4, I could go all the way to 0. That's 4 boxes. And then I'm going down another 5. So my total distance is down 9. So this is where I would like you to write -9, not just that 9. Even though it is 9 boxes, I do want you to have some sort of knowledge that, hey, this one's definitely going down. And then across, I'm at -1 and I've got to get to 2. And I've got to go across 3 boxes. Because the gradient's just how far up and down divided by how far across, we've got -9 divided by 3, which is equal to -3. The -3 is actually saying that it goes down 3 across to the right 1. Down 3 across to the right 1. And we can see this pattern playing out again and again, just in smaller triangles. What's really important to remember is that the negative matters. This one is going downhill, so I know for sure my answer was going to be negative before I started, so the -3 makes sense. Just remember that that negative in front of the 3 is incredibly important, so always just have an idea in your mind before you get started. So we do the same thing even if it's not as steep. In this example here, we're going from -1 up to 3, 0. So all we've got to do this time is start at the lower point, right? The point furthest to the left, and we go up 1 spot and then across 2. So this means that the gradient is how far up divided by how far across. So it's 1/2. This is equal to 0.5, but you can legitimately write 1/2. That's telling us what the pattern is. Up 1, across 2. Again, we can break this into smaller triangles to see if this pattern holds. If we go all the way over to the left of the graph, it goes up 1, across 2. Up 1, across 2. So we know that this is the pattern. So if we have a look at 2 lines that are very similar, right? The red line has a gradient of 3.5 and the black line has a gradient of 1.5. They're both passing through the same y-intercept. So what's the difference? All that we're saying, the big difference between these 2 lines is that the 3.5 is going up 3.5 squares and then across 1, whereas the black line is going up 1 across 2. Anytime that you need to know if a line is steeper or flatter, the bigger the number, right? So the 3.5 is bigger than 1/2 or 0.5. Bigger means steeper. So the closer we get to 0, the flatter the line's going to be. And this is the same for a negative number. It's just how big the number is. So -0.5 would be a very flat line going slightly downhill, whereas -10 would be a super steep line going downhill. So the bigger the number, the steeper the line. Another way to think about finding the gradient is instead of change in y divided by change in x, all you've got to do is find the rise and divide that by the run. Rise over run is a very common saying to kind of remember how to find this gradient from a graph, but we just need to know that the rise is how far up and down and the run is how far across. Just because it says rise doesn't mean it has to go up. We can have a negative rise, and that's anytime our thing is going downhill. Rise over run could be an easier way for you to remember how to find the gradient from a graph. Please just draw your triangles. The big pro tips for this lesson are draw your triangles every single time if you can on your graph. And just remember that the gradient is the change in y divided by the change in x. Thanks so much for watching this lesson, and I'll see you later.